Good morning everyone. Welcome to my channel Mathematics Foundation. Before going to start, if you like my videos, please like, share, comment and subscribe my channel. Today I will explain some important points of first chapter, that is real numbers, of your textbook. Let's discuss now. What are natural numbers? Natural numbers, also known as counting numbers, are the numbers beginning with 1, with each successive number greater than its predecessor by 1. For example, 1, 2, 3, 4, etc. What are prime numbers? The natural numbers which are divided by 1 and itself are called prime numbers. Or you can say like this: a natural number is said to be a prime number if it has only two different factors, namely 1 and the number itself. For example, 2, 3, 5, 7, 11 are prime numbers. All these numbers have two factors, 1 and the number itself. Now, these are important points, notes about prime numbers. 1 is not a prime number. The only even prime number is 2. The smallest prime number is 2. The smallest odd prime number is 3. All prime numbers are odd except 2. What are twin prime? A pair of prime numbers is said to be twin prime if they differ by 2. For example, 3, 5, 11, 13, etc. are all twin prime. Here you see 5 minus 3, 2, 13 minus 11, 2, 19 minus 17, 2. That means if difference between two prime number is 2, then they are said to be twin prime. What are co-prime? A pair of numbers is said to be co-prime if the numbers have no common factor other than 1. Or two natural numbers are said to be co-prime number whose HCF is 1. That is, if the HCF of two numbers is 1, then the numbers are said to be co-prime. For example, 2, 3, 5, 9, all these numbers have HCF 1, so they are co-prime numbers, and these are not co-prime numbers because their HCF is not 1. Composite numbers. A natural number is said to be a composite number if it has at least three different factors, that is more than two factors. Example: 4, 6, 8, 9, etc. are composite numbers. So, notes about composite numbers. 1 is not composite number. Smallest composite number is 4. Smallest odd composite number is 9. What are perfect numbers? A number is said to be a perfect number if it is equal to the sum of its factors other than itself. I have taken two examples. 6. Factors of 6 are 1, 6, 2, 3. And factors of 28 are 1, 28, 2, 14, 4 and 7. Now, sum of the factors of 6 other than itself, that is, if I have not taken 6, other factors are 1, 2 and 3. So 1 plus 2 plus 3 equal to what? 6. Similarly, factors of 28 except 28, you will get 28 after adding on these factors. So 6 and 28 are perfect numbers. Whole numbers are natural numbers. All natural numbers including 0 are called whole numbers. For example, 0, 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5 are natural numbers. If I include 0 here, then you will get the set of whole numbers. Integers, the numbers 0, plus minus 1, plus minus 2, plus minus 3, etc. are called integers. Here the numbers 1, 2, 3 are called positive integers, whereas the numbers minus 1, minus 2, minus 3, etc. are called negative integers. 0 is neither positive nor negative integer. Even number, a natural number is said to be even number if it is divisible by 2. For example, 2, 4, 6, 8, etc. are examples of even numbers. What are odd numbers? A natural number is said to be odd if it is not divisible by 2. For example, 1, 3, 5, 7, 9, etc. are examples of odd numbers. Consecutive numbers. A series of natural numbers, each differing by 1, is called consecutive numbers. For example, 50, 51, 52, 53, etc. are consecutive numbers. Here you see 51 minus 50, you will get 1. 52 minus 51, you will get 1. So these are consecutive numbers. What are rational numbers? A number which can be expressed in the form p by q, where p and q are integers and q not equal to 0, is called a rational number. For example, 4 is a rational number since 4 can be written as 4 by 1, where 4 and 1 are integers and the denominator 1 is not equal to 0. Similarly, the numbers 3 by 4, minus 2 by 5, etc. are also rational numbers. What are recurring decimals? Recurring decimals are also rational numbers. A recurring decimal is a number in which one or more digits at the end of a number after the decimal point repeats itself endlessly. For example, 0.333, 0.1111, etc. are all recurring decimals. After decimal point, these numbers are repeating itself. So these points you remember. Between any two numbers, there can be infinite number of other rational numbers. Any recurring decimal can be expressed as a fraction of the form p divided by q, and hence it is a rational number. So we can express recurring decimal in the form p by q, that is, recurring decimals are rational numbers. Irrational number, the number which cannot be expressed in the form p divided by q, where p and q are integers and q not equal to 0, are called irrational numbers. For example, root over 2, root over 3, pi, root over 10, etc. are irrational numbers. So these are important points about irrational numbers. In decimal notation, non-terminating and non-repeating numbers are called irrational numbers, as they cannot be represented in the form p divided by q. If an integer is not a perfect square, then root over n is an example of irrational number. For example, you see 2, 3, 5, etc. are not perfect square. So root over 2, root over 3, root over 5, etc. are irrational numbers. What are real numbers? Real numbers are the numbers that are either rational or irrational. That is, the collection of rational and irrational numbers are called real numbers. For example, 2, root over 2, 5, 6, 9 divided by 4, 6 divided by 9, pi, etc. are real numbers. That is, the set of real numbers means irrational and rational numbers taken together. Decimal representation of rational numbers. This is theorem 1. Let x equal to p divided by q be a rational number such that q not equal to 0 and prime factorization of q is of the form 2 to the power of m into 5 to the power of n, where m and n are non-negative integers. Then x has a decimal representation which terminates. That is, you see here 0.275 equal to what? 275 divided by 1000. After simplifying, you get 11 divided by 2 cube into 5. Now, if you compare 2 cube into 5 with this, you will get m equal to what? 3 and n equal to 1. So, if you can express the denominator in the form 2 to the power m into 5 to the power n, then those numbers terminates. This is theorem 2. Let x is equal to p divided by q be a rational number such that q not equal to 0 and prime factorization of q is not of the form 2 to the power of m into 5 to the power of n, where m and n are non-negative integers. Then x has a decimal expansion which is non-terminating, repeating. That means 5 divided by 3, see 1 into 6, 6, it is non-terminating because I cannot express this number in the form 2 to the power m into 5 to the power n. 5 by 3, 3 you cannot express in the form this. So please like, share, comment, and subscribe my channel. In next video, I will explain some more points of real numbers.